This is the first in a series of tutorials on supply chain modeling and network optimization using Logix. In this tutorial, we'll show you how to use Logix to model the location and number of distribution facilities throughout your distribution network to optimize cost and service. We'll cover setting up your first supply chain model, entering your data, viewing your model, and optimizing a simple supply chain network. In our first model, we're only going to enter customers and demand data and solve a purely greenfield network problem from scratch without any known distribution centers, suppliers, or other supply chain entities. We've already created the How to Add Customers demo model, which you can access directly from Logix at any time. This is what the model looks like in Logix. But for now, let's get started by looking at how to set up the data using Logix and creating the model ourselves from scratch, just like you'd create your own models with your own data. Creating your first network model. In our first very simple model, we'll start with just customer demand. You'll usually use Excel to import all your data, including demand, into Logix. The templates and formats that come with Logix show you how to set up demand volume or any other data type. You can find the import templates in the same folder where you installed Logix. Double-click on the Import Templates Excel file to start this process in Excel. You can view the format for each of the supply chain types as well as example datasets for any of our demo projects. Click on Customer Format, and the spreadsheet shows the basic format and maximum field length for customer demand. Be sure to familiarize yourself with these templates and note that you can leave most of the fields blank if you don't have the data or if your project only has a few or even one product type like our example demo project. For now, click on the Customer Data Demo example in Excel and view the customer demand data we've already entered for our project. Setting up your data in Excel. In this case, we've entered demand for each customer. Usually, you might use weight or gallons or even revenue for demand. Under this column here, Quantity A, we've entered demand for each of our customer areas represented by population and a major city for each state. So we really only have 48 demand points or customers in this small model with only one product type. We also have the required site name, city, state, and zip code, as well as the optional region, latitude, and longitude, count or number of shipments, and the size represented by this quantity. In this case, we're using square feet, but you can use cases, pallets, cubic meters, or any other measurement of size. Logix is able to geocode your locations, so latitude-longitude can be left blank, which will require an additional geocoding step in Logix. Remember, always include an end-of-line or EOL data entry at the end of each line. Any valid entry is fine. Again, in this very simple model, we're only going to use customer demand data. So, save your customer file as a CSV or comma-separated variable file with any name you choose and to any file folder you'd like. Then remember to close Excel. Starting Logix. Now that we have our data, we're going to kick off a Logix session. Enter your password, or if you've entered your password previously, just click on Remember Me and then click on Logix 9.0 for the latest version of Logix. Next, from the startup screen, simply click on New Project. If you have already started a project and want to continue from where you left off, you would click on Current Project. For a new project, we're presented with a blank template and we'll import our data using the Data Import Wizard. Importing your data. From our Logix project screen, just above the Design Center panel, click on the Data Import Wizard icon. These are a handful of features and icons you'll use all the time, so they are immediately available. If this is the first time you are using the Import Wizard, you will need to install it. Then, once it starts, you will always load data for each of your supply chain types individually. In this case, click on Customer Demand. Next, browse for the customer data file we saved previously. Lastly, click the Import button. If there are any errors in the format or size of any of your data fields, Logix will highlight the error and the line number and request that you fix the problem and re-import the data. Logix loads your data representing exactly what we just saw, all the demand for each of our states, site name, city, state, zip, region, and any other data we entered. The comprehensive data listing screen shows all your supply chain entities, and in this case, the data listing shows only the 48 customers or demand points and no distribution centers, no cross-docks, and no suppliers in this model. Geocoding our data. Once we have loaded our data, we may need to geocode any location for which you haven't entered a latitude and longitude. If any of your demand points contain the symbol L/L, these have not been geocoded and may need attention. First, click on the Parameters icon in the Design Center panel and then click on the Geocode Data tab in the Parameters screen. From this screen, select the geocode database you wish to use. In the United States, you can choose either 3-digit or 5-digit zip code geocoding depending on the level of detail you have entered for zip code in your data. You can also choose from a number of international geocode databases to use Logix outside of the United States. Then, in the Design Center, click on the Last Round button at the top. This takes you to your Settings panel, and from here, click Geocode All. Logix will geocode all your entries and provide a summary statistic of the results. You may need to use another geocode database, such as Canada or Mexico, if some of the locations have not been geocoded, and repeat this process. Viewing demand points. All of our demand points are displayed here in the Show Data listing, which we're always able to access by simply clicking on the Show Data icon. Click any of the top Design Center buttons to access different supply chain design features. These are grouped in the Design Center panel to make your modeling easier. Just click the top buttons to access network modeling, transport optimization, scenarios, reports, or settings. Viewing the supply chain modeler and maps. So let's first take a look at our data using the supply chain modeler. Click on the icon for the supply chain modeler, and we can view our 48 customers using very familiar Google Maps, which Logix uses for all of its map functionality. You can also click on the map icon above to view the same pop-up maps in your default browser. All of our demand points are represented here, and you can click on any demand point to show details for that customer. We'll later see how to show smaller or larger-sized customers with different sized icons, or even different icon shapes that you might prefer. Default and general model parameters. We also should add a default record to every project with many of the parameters specific to your model. If the data listing doesn't show a default record, you can enter one by simply clicking on the Add Sites icon, which pops up the detailed Add Sites screen and all of the supply chain types available in Logix with the default option already selected. Or, if the data listing shows that you already have a default record, just click on that line and from the pop-up editor, click Details and the detailed site record immediately appears. In either case, we need to have a ship unit, or the basic quantity represented by one shipment for each of the product categories that we are including in our model. We only have one product category in our simple model, and the ship unit is simply 100, which means our transportation rate will be per hundredweight. This can also be, for example, 15, which means our average package size is 15 pounds. Or even perhaps 40,000, which means our average transportation rate is per truckload. Next, we'll enter our default transportation rate. Our transport rate for this model is simply $0.0075 per mile per hundredweight. There's no fixed transportation cost, just a variable rate per mile. We also have an average fixed warehouse cost of $1,350,000 per year for a typical warehouse facility and a variable rate of $4.50 per square foot. The variable cost will be automatically calculated by Logix for the required warehouse size using this variable rate. Keep in mind, in this simple model, we are not including any specific warehouse facilities or even candidate sites for which you'd likely enter specific warehouse costs and variable rates depending on the facility or locality. And you'll note we have an entry for square feet per queue or square feet per quantity. This might also appear as size per queue. This simply means that we have not entered specific size data for each of our customers. We just entered weight for our quantity measure. So this factor automatically translates our quantity or weight into size or square feet for each of our demand points. This is a useful way to simplify our model, but you can also include specific size data with your customer data instead of using this factor. In our model, size is simply 1/1000th of the weight, so 1,000 pounds takes up 1 square foot. Go ahead and enter this data. Be sure to click the Select button at the bottom and then save this record to continue. If you already have a default record with these values, just close the record. Viewing the display and project parameters. Now let's take a look at some basic project parameters we'd like to use with our model. You are always able to click on Parameters in the Network Design Center panel to see what options you have turned on. At the bottom of the screen, you can also see a recap of many of our parameters to quickly review what we've selected for our model. In our model, we've selected quantity as the primary reporting measure, but you can click on size or count as well. Since our size measure is square feet, you can enter square feet and Logix will show this in its various screens and reports. Now, we're going to take a look at how we want to display our data in our solution and reports. In this case, we've selected to display distance instead of end-to-end time or outbound delivery time. There are a lot of project parameters that we can turn on or off or change, whether in network optimization or transportation optimization, rates and distances, and geocoding that can affect our solution and reports. When you've finished with this tutorial, you can go back and try any of these options and reports and see which metrics are most relevant to your project. Now that we have all of our data, we'll just run a very basic network optimization model with different parameters for different scenarios. Start from our main project screen. First, we can choose the number of distribution sites we want to optimally locate. In this particular model, we have no distribution centers, either existing or candidate, to work from. We basically have a greenfield model with just demand and customers, so we want to turn on greenfield optimization. Optimizing our supply chain model. To turn on the greenfield option, go to Scenarios or the third button under our Design Center and click on Greenfield to turn this option on. In Greenfield mode for this model, we don't have to have any candidate sites available to us at all. Let's enter 1 for the number of sites to optimally locate just one distribution center for the entire model. Be sure to click on the first radio button in the Design Center and then click on the Network Optimizer icon. Viewing the results. In a few seconds, Logix solves this optimization problem and locates the one site in Bloomington, Indiana, approximately 92 miles south of Lafayette, Indiana, to serve all of these sites at the lowest cost. The solution is comprised of transportation costs and warehousing costs, where warehouse cost can be fixed or lease cost for the facility, as well as variable per square foot costs associated with the size of the facility required for this distribution center. We can also view our supply chain modeler and maps of this solution. Click on Supply Chain Modeler and the map shows the site centered on Bloomington, Indiana. Alternatively, you can click on the map icon at the top of the Logix screen for a larger pop-up map view, which opens in your default browser. Now, we'll try to optimize 2 sites and we'll enter 2 for the number of sites. Again, clicking on Network Optimizer results in the optimum 2-site solution, one in San Francisco, California, and the other in Carlisle, Kentucky, just outside of Louisville, Kentucky. Click on Supply Chain Modeler or the map icon to view a map of our solution. As you can see, the optimum 2 sites for this problem are located at these points on our map and serve these customer areas shown with the same color icons and connecting lines. If you want to truly optimize your network and set up the ideal network from scratch, leave the number of sites blank and again click Network Optimizer. In the message that pops up, choose to optimize both the number and location of distribution facilities that will achieve the best balance of transportation and warehousing costs, since we know transportation costs generally come down with more distribution facilities and warehousing costs generally go up with more sites. Logix will take a bit more time with this problem and again displays the complete solution showing the optimum 5 sites and their distribution areas, as well as all the cost and service factors for the optimum greenfield solution. In our next video, we'll explore more features of the Logix supply chain optimization like adding distribution sites, suppliers, and other data. For now, try changing any of the demand data in your model and see how the optimum solution is affected. Or use your own demand data and solve the greenfield model again for your particular supply chain. Feel free to explore the many reports, maps, analytics, and charts in Logix, and then go on to the next tutorial. All the best till next time.